Hello everyone, this is the first lecture of this course. In this lecture, we will introduce some basic concepts about indoor and outdoor hot and humidity environment. The task of building thermal engineering is to explain the principles of building thermal engineering and to discuss how to effectively protect or utilize the effects of indoor and outdoor heat and humidity through architectural design and planning and design, and reasonably solve the problems of thermal insulation, moisture resistance, energy saving, etc., to achieve the purpose of creating a good indoor thermal environment, improving the durability of the enclosure structure, and reducing the energy consumption of heating and air conditioning. Then the outer enclosure structure of the building divides people's living and working space into indoor and outdoor parts. The building thermal environment is also divided into indoor thermal environment and outdoor thermal environment. The thermal environment of the building is designed to be comfortable, healthy, and efficient. Indoor air temperature, air humidity, airflow velocity, and ambient radiation temperature constitute the four elements of indoor thermal and humid environment. These elements have different combinations with human activity levels and clothing conditions, and the indoor heat and humidity environment is roughly divided into comfortable, tolerable, and unbearable conditions. The simplest, convenient, and widely used indicator is room temperature. However, only using room temperature as an evaluation index is not perfect. If the wind speed, humidity, and radiation temperature are not considered, the room temperature of 30 degrees Celsius is warmer than that of 28 degrees Celsius, but the room temperature of 30 degrees Celsius and the wind speed of 3 meters per second is more comfortable than the room temperature of 28 degrees Celsius and the wind speed of 0.1 meters per second. Therefore, for multi-factor evaluation, it is often to look for a single indicator that can replace the joint action of multiple factors. The comprehensive indicators for evaluating the indoor thermal and humid environment mainly include effective temperature and PMV/ppd indicators. Effective temperature is a comprehensive index proposed by the United States, which considers three factors of air temperature, air humidity, and wind speed. This figure reflects the calibration experiment for effective temperature. Room A is a reference room for setting the effective temperature. The relative humidity of the air is constant at 100%. The wind speed is constant at 0.1 meters per second, and the air temperature changed by 1 for each experiment. Room B has three environmental elements, including temperature, humidity, and wind speed, which can be combined arbitrarily. By adjusting the temperature, humidity, and wind speed of room B, the subjects have the same thermal feeling in the two rooms. At this time, the temperature of room A is the effective temperature of room B. For example, when the temperature of room B is 25 degrees Celsius, the relative humidity is 50%, and the wind speed is 1.5 meters per second, and the temperature of room A is 20 degrees Celsius. The subjective thermal sensation of the two rooms are the same. The effective temperature of room B is 20 degrees Celsius. Since the effective temperature only considers three of the four elements of the environment, and does not consider the radiation temperature, the black globe temperature is used instead of the air temperature, and a new effective temperature is proposed. After that, the standard effective temperature was proposed by considering the human activity level and clothing. The PMV/ppd index consists four environmental factors, including temperature and humidity, wind speed, radiation temperature, and two human factors, human activity level and clothing. PMV is a predicted average evaluation index, which represents the feeling of the vast majority of people in the same environment. PPD is a predicted dissatisfaction percentage indicator, which indicates the percentage of the population that is dissatisfied with the thermal environment. This figure shows the relationship between the two. It can be seen from the figure that when the PLV is equal to 0, the PPD is 5%. This means that when the indoor thermal environment is in the best thermal comfort state, there are still 5% of people who are not satisfied. Therefore, ISO 7730 recommends a value of plus or minus 0.5 for the PLV indicator, which is equivalent to allowing 10% of the population to be dissatisfied. Next, let us learn about the physical properties of humid air involved in several building thermal calculations, including water vapor partial pressure, air humidity, and dew point temperature. Physical properties of moist air. The particle pressure of water vapor is the pressure produced by the water vapor part of humid air at a certain temperature. The total pressure of humid air is equal to the sum of the partial pressure of the dry air and the partial pressure of the water vapor. When the humid air is saturated, the excess water vapor will condense into liquid and precipitate. The partial pressure of water vapor in saturated humid air is called the partial pressure of saturated water vapor. Humidity indicates the degree of dryness and wetness of the air, including absolute humidity and relative humidity. Absolute humidity refers to the weight of water vapor contained in a unit value of air. Relative humidity refers to the percentage of absolute humidity of humid air to the saturated water vapor amount at the same temperature and pressure at a certain temperature and atmospheric pressure. At the same temperature, it can be approximated that the actual water vapor partial pressure is proportional to the absolute humidity in the thermal engineering design of buildings. Therefore, relative humidity is also the percentage of the partial pressure of water vapor in the air to the partial pressure of saturated water vapor at the same temperature. Relative humidity is widely used in thermal engineering design of buildings, and relative humidity can express the influence of humid air on human thermal comfort, indoor thermal and humid environment, and the wet condition of the building envelope. The dew point temperature is recorded as Td, with the temperature at which unsaturated air reaches a saturated state due to cooling under the condition of a certain atmospheric pressure and constant air moisture content. Next, let's do an exercise. It is known that the indoor temperature of a room is equal to 18 degrees Celsius, and the relative humidity is equal to 61.1%. Find the dew point temperature. First, the saturated water vapor partial pressure corresponding to the room temperature of 18 degrees Celsius is 2062.5 Pa. Secondly, using the calculation formula of relative humidity, the actual water vapor partial pressure is obtained to be equal to 1260 Pa. Then, according to the definition of dew point temperature, it is found that the temperature corresponding to 1260 Pa as the partial pressure of saturated water vapor is 10.4 degrees Celsius. That is, the dew point temperature is 10.4 degrees Celsius. The outdoor heat and humidity environment refer to the general term for all the heat and humidity physical quantities acting on the building envelope. Building thermal design mainly considers the physical quantities that affect the indoor thermal and humid environment. Building durability and overall building energy consumption, mainly including air temperature, humidity, solar radiation, and wind, etc. The annual and diurnal changes of air temperature are both periodic, because the solar radiation that causes air temperature change is periodic. The diurnal variation of air temperature varies from place to place. This is caused by the day-night balance of solar radiant heat and long-wave radiation. Solar radiant heat is one of the parameters of the outdoor thermal and humid environment that has a greater impact on buildings. When sunlight passes through the Earth's atmosphere, due to the reflection of clouds and scattering and absorption of gas molecules and various particles in the atmosphere, the radiation intensity reaching the Earth's surface is greatly weakened. The intensity of solar radiation reaching the surface varies greatly depending on the geographic location. The solar radiation reaching the ground include direct radiation and scattered radiation. Direct radiation is the part of the sun that reaches the ground directly. Scattered radiation reaches the ground after being scattered by the atmosphere. The sum of the two is the total radiation. The water vapor in the air comes from the evaporation of surface water. In the process of water evaporation, it is necessary to absorb the latent heat of vaporization, which directly or indirectly comes from the solar radiation heat. Since the partial pressure of saturated water vapor in the air changes with temperature, the absolute humidity of a region has little change in a certain period of time, but the relative humidity changes sharply. Wind is divided into atmospheric circulation and local wind. Atmospheric circulation is the constant activity of the atmosphere from the equator to the poles and from the poles to the equator, due to the uneven irradiation of solar radiant heat on the Earth's surface, causing the temperature difference between the equator and the poles. Local wind is the airflow caused by uneven heating or cooling in a local area. In this picture, picture A is the waterland wind, picture B is the mountain valley wind, and picture C is the forest plain wind. Think about it, how to use architectural design to organize and generate wind in buildings, how to avoid low temperature and frosting on the ground floor of buildings, in bases and low-lying areas. Which areas are suitable for the use of wind energy?